Hi everybody, this is lesson 5.8 and we're going to be talking about polygons. Now this is a special lesson because it's our last one. That's right, we're at the end of our semester. So congratulations, you've made it all the way through, but we got to get through this lesson. Okay, so what I'm going to teach you in this video is about different polygons and then also how to calculate the sum of the interior angles in a polygon. But first of all, what is a polygon? A polygon is a two-dimensional shape. If you look anywhere in the world, you should be able to find different polygons all around. And there's some examples at the bottom. My favorite is the middle, because obviously it's so colorful, it's beautiful. It is a quilt, and a quilt is where you take several pieces of fabric, sew them together, and they make a colorful blanket. And so you'll notice that this blanket is made up of many different shapes inside the design. And on either side of the middle diagram, you'll see road work, tiles, brickwork. Even within those, I'm sure you can see several different polygons or shapes. And so if we have so many different kinds of shapes, we need a way to name them, some sort of a system. On the left-hand side, you'll see a table that has a system where we name the polygon based on the number of sides it has. So if it has 3 sides, we call it a triangle. And I know that you know a triangle has 3 sides, but did you know that that's because the very first part, which we call a prefix, tri means 3. So it's like a 3-sided shape. A 4-sided shape is called a quadrilateral because quad means 4. And you're going to be like, well, but I thought a 4-sided shape was a square or a rectangle. You're right. Those are types of quadrilaterals, but any 4-sided shape is called a quadrilateral. Okay, like a pentagon, penta means 5, so that's a 5-sided shape. Hexa means 6, hepta means 7, octa means 8, nona means 9, and deca means 10. And I'm sure it keeps going. All of these are called gon because they're polygons. So pentagon means 5-sided polygon or 5-sided shape. I'm just going to use n if they ever give you a weird number of sides. So someone could ask you, well, what about a 100-sided shape? Well, I don't know what it's called, so I'm just going to call it, instead of n, I'm going to call it 100 gon. Okay. That's a little bit messy, but you know what I mean. On the right-hand side, we have another table that's just describing what a regular versus an irregular shape would look like. So even though we know a 3-sided shape is called a triangle, a regular triangle will have all the sides the same length, whereas an irregular triangle might have different lengths for all 3 sides. Just like the very last one, 8 sides is an octagon. So this is regular, where all the sides are the same length. So it looks like a stop sign. But an irregular octagon, even though this one has 8 sides, each of the sides might be a different length, and so on. So it looks kind of weird. All right? Let's focus more on the regular polygons. So remember, all the edges, so all the side lengths, and all the corners, the vertices, have to be congruent, which means they have to be the same. So a regular polygon has all the sides are the same. That's why this is an equilateral triangle. And all the angles have to be the same. So the interior angles, 60 degrees, this 60 degrees, and this 60 degrees have to be the same. Okay? Now those are called interior angles because they're inside the shape. We can also add them all together. 60 plus 60 plus 60 is 180. So 180 is the total of all those 60s, all the corners. You'll notice that every 3-sided shape, every triangle, when you add up all the corners, they always add to 180. And that changes depending on the shape. So a quadrilateral that has all the sides the same is a square. And notice that each corner is a 90 degrees. Okay, so that's 4 90 degrees. 4 times 90 will give you a total sum of 360. So 90 plus 90 plus 90 plus 90. That means any four-sided shape, all the corners should add up to 360. So we can keep going. Let's say the hexagon. The hexagon has 6 sides. So this is 120, this would be 120, this one, this one, this one, this one. There's 620. So if you multiply them all together, that means the grand total is 720 for the sum of all of those individual angles. Notice that as you go higher and higher with the number of sides, the bigger and bigger the green number is going to be. So you know what, I don't have enough time to count all of that. I just want to have a formula that helps me. So to find the sum, all I have to do is use this formula where n is the number of sides, and I'm just going to plug that in right there, and just use the rest of the formula to figure out that green number for me. Okay, so let's see an example. Example number 1, find this sum of the interior angles of a 13agon, so a shape with 13 sides. I also want to know what one angle is. So one angle means once you're done, can you figure out with what just one corner? Like, what is that one corner equal to? And remember, they're all the same. Okay, so let's find the green number first. We're going to use the formula. S equals, and then we need our n, which is 13 because we have 13 sides in our shape. Okay, just follow the formula, minus 2 times 180. All right, now we're going to figure out the answer to S, and we're just going to do BEDMAS. 13 minus 2 is 11 times 180, and that's going to be 1,980. Okay, so that is my green answer. That means if I decided to draw a 13-sided shape, I don't know how to draw a 13-sided shape, that means the entire inside, all of these individual angles is going to add up to this. All right, so I'm just going to go, therefore, the sum of the interior angles is 1,980. Now, we still have to answer this question. So that question says, well, what about this? How much is that? Because there's 13 sides, there must be 13 of those angles. So I'm going to take this guy and I'm going to divide it by 13 to figure out how much each of them are. But I'm going to do this a little bit neater. I hope you're okay with me using E for each. Take the total, 1,980, and because I want to know what each one is, and there are 13 angles, I'm going to break them up, that big sum, up into 13 pieces. So each angle should be about 152.3 degrees. All right, so this one right here is basically telling you that each of those corners is 152.3 degrees. All right, so then we just write a quick therefore one angle is 152.3 degrees. All right, let's try the next one. Number 2, what is the measure in degrees of the total sum of the interior angles? Whoops. Let's use the same color. So we're looking at a 12-sided shape, okay? And again, we want to know what one angle is. So remember, the sum is everything in the middle, and the one angle is talking about just each of these corners. Okay? So we do the exact same thing. I'm going to put 12-sided right here. Okay, actually, you know what? I should probably show you. It's going to go right into our n. And then we calculate the entire total of all of the angles altogether, which is 1,800 degrees. That's made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles. So we have to divide it by 12 to get each of those angles. and each of the angles is going to be 150, which you see right here. Okay, so if you take 12 times 150, you're going to get that 1,800 degrees as the total sum. Now here's our last question. This one's a little bit more tricky. Example number 3, ABCD is a parallelogram with all sides the same. Okay, so they're telling you that all the sides are the same. And angle B is 80 degrees. Okay, so they told you that this one is 80 degrees. And because all the sides are the same, this is kind of like saying, well, actually, that means this one is also 80 degrees. And that means this one isn't necessarily 80. They kind of want to know what that is. What is the measure of A? So you know what? What I'm going to do is I'm just going to call this X, and the one opposite of it is going to be exactly the same. Okay, so let me get rid of some of this so that you can see. Let's try this one more time so you can see everything, and we can make an equation. X. So this question is a little bit different now. 80, 80. All right, because this is a quadrilateral, four-sided shape, we know that the total insides should be 360 degrees. Okay, because we had that, let me go back right, oops, here. Right, four-sided shape should be 360 degrees. Sorry for switching so much, there we go. All right, so what I did was I created an equation right here that said this angle plus this angle plus this angle plus this angle should give me 360. So that's what my formula says right here. And I just added the two reds together to get two X's. I added the two blues together to get 160. And I started to isolate for X. So I brought the 160 to the other side and made it a negative 160. When I subtracted, I got 200. And then just remember this last step. To get rid of the 2, you're going to divide by 2. You have to do that to both sides. So those go away, and 200 divided by 2 is 100. So that means that this X and this X have to be 100 each. And you'll notice that when you take 100 plus 100 plus 80 plus 80, you're going to get that 360 degrees. All right, so that's the end of our very last lesson. The homework is right here, and I hope that you guys had as much fun teaching, well, going through this lesson as we did teaching it. Okay, see you all later. Have a great day.